Each panel is molded from actual poplar or American chestnut bark, then made from a tough closed-cell polyurethane. The result is a siding that delivers solid insulation, about R4.7 per inch, and stands up to impact, bugs, and decay. It's also hand-painted with UV-stable colors that look natural and stay that way over time. There are 4 styles to choose from. The Elite series uses larger panels, nearly 29 by 17 inches, that give up to 3.79 square feet of coverage, depending on the species. It has thick texture and deep relief, with some edges reaching 3.5 inches. The Old Style series has a squarer shape, about 17.5 inches on each side, a more compact profile, and comes in 3 tones: poplar gray, earth tone, and chestnut timber brown. Slim Pro is all about speed, with thinner panels in 2 sizes: Standard, 20 by 16 inches, and Big Dan, 24 by 24 inches, which covers a full 4 square feet at once. The Patriot series mixes panel patterns to create a more random, natural look, with an easy-to-install lapped edge and a 16-inch reveal. Installation uses a system called Vapor Lock, where each panel locks into the one above it using hidden flanges. They go over rigid plywood, or OSB, with a breathable house wrap. Screws secure the pieces from behind, though a few may go through the face in specific spots. Panels need to sit for 24 hours before install to adjust. Trim corners can be boxed or mitered, and caulk helps seal the seams. Once up, the panels look almost indistinguishable from actual bark. They work on gables, walls, pillars, and even interior spaces where natural texture makes a statement. This foundation system starts with a grid of plastic waffle box forms that shape a 2-way ribbed concrete slab. Standard post-tension cables are threaded in both directions through the ribs, adding strength and helping the slab stay stable when the ground shifts. Steel rebar runs alongside the cables, held in place by special clips that lock everything into position. Once everything's set, concrete is poured in a single step, with the right cover over the cables, following established engineering codes from the Post-Tensioning Institute and the International Building Code. What makes this system stand out is how little of it actually touches the soil. Only the ribs make contact, which means less pressure from swelling or shrinking ground. The spaces between ribs let the soil move around without pushing up on the slab. By focusing the weight onto specific points, the system creates higher pressure exactly where it's needed, helping resist ground movement more effectively. The process is quick and consistent. Level the site, set the waffle boxes, secure the cables and rebar, pour the slab, let it cure, then apply tension. From start to finish, it usually takes just 3 or 4 days, much faster than typical slab construction. It's been used in everything from single-family homes to apartment buildings and light commercial spaces, especially in areas with clay, loose soil, or rock, where traditional foundations often struggle. Beyond performance, it saves on materials. The slab uses less concrete and steel, and there's less soil to haul off-site. Since it was introduced in 1993, over 30 million square feet have been installed across the US without a single reported structural failure. The PERI public stair is designed for real-world demands. Crowd-heavy events, public access points, and temporary structures that need to meet strict safety standards without slowing things down. It offers stair widths of 1.5, 2, or 2.5 meters, and the base footprint for a stair tower starts at 3.25 by 5.5 meters. It's rated to handle heavy use, with stairs and landings supporting up to 7.50 kN per square meters, and guardrails standing strong against 2 kN per square meters lateral force. This system fits into the existing PERI UpFlex grid and reuses most of the standard parts: decking, guardrails, base plates. So there's no need for a full overhaul. Only 7 extra parts are needed to turn standard scaffolding into a public staircase. The setup is simple. Components lock into place without tools, using a proven node and ledger system. Stair treads and guardrails secure firmly using hooks or the gravity lock. You can fine-tune the stair height in 25 centimeter steps and small changes in elevation. It works across a range of layouts, including single flights, U-shaped designs, or full stair towers, with or without central openings. It can withstand wind loads of 0.20 kN per square meters and reach up to 12 meters high under standard use. For taller builds, PERI provides structural verification. Ideal for stadiums, exhibitions, or temporary access routes, the system adapts quickly to different needs. It installs fast, integrates cleanly with existing structures, and handles the pressure of high foot traffic. Blocking sound, especially those deep, low-end rumbles, isn't something most panels handle well. This one does. Each sheet measures 4 by 8 feet, is 3/4 of an inch thick, and weighs around 26 pounds, covering about 32 square feet. It's made from dense recycled wood fiber, clocking in at roughly 14 pounds per cubic foot, with a thermal resistance of R2.45 per inch, and water absorption kept under 4%. Inside, a mix of densities and tiny air pockets help break up sound across a wide frequency range, including bass tones below 125 Hz. On its own, it offers an STC rating of about 27, but paired with drywall, insulation, and resilient channels, it helps walls and ceilings reach ratings as high as 68, depending on how it's installed. Tested to meet ASTM standards, it holds up under pressure. More than 60 pounds per square inch of tensile strength, and 20 pounds per square inch of compressive strength and minimal expansion. It stays solid and doesn't swell out of shape. Made entirely from recycled material with no formaldehyde or VOCs, it's safe for indoor use and supports green building certifications like LEED. Installing it is pretty easy. Screw it into studs or existing drywall with screws every 12 inches. Then run resilient channels across, every 24 inches on walls, 12 inches on ceilings, followed by 2 layers of drywall. Use acoustical sealant along every edge and seam to lock in performance. The dimpled side of the panel should face inward, towards the framing. You can cut it with a circular saw or a sharp utility knife. Keep the panels dry until they're in place. For electrical boxes, leave at least 30 inches between outlets, and, if needed, frame them out with panel scraps to keep sound from slipping through. Instead of digging, pouring, and waiting for concrete to cure, this system installs steel screw piles straight into the ground using a mechanical driver. Each pile is made in a factory, so every piece meets strict standards for strength and shape. The threads and helices are designed to grip the soil as they go down, locking in place and supporting a wide range of loads, from small buildings to larger infrastructure projects. Because there's no excavation or on-site mixing, the work goes quickly. Crews need less equipment, fewer steps, and don't have to deal with messy concrete or drying time. The process is cleaner and quieter, with minimal disruption to the site. It also means fewer vehicles, less waste, and a shorter overall timeline. Developed by KIBAG Bauleistungen, this screw pile method replaces traditional cast-in-place concrete foundations. It's especially useful where digging is difficult or limited, like tight city spaces, areas near water, or ground that's protected for environmental reasons. In projects where the structure might be temporary or moved later, the piles can even be removed, assuming they're designed that way. Compared to the older concrete approach, which involves several stages and depends heavily on weather and soil conditions, this system moves most of the work off-site. That shift brings more predictability and consistency. On-site, it's all about speed and simplicity. One rig, one step, and the pile is in. Each twist block measures about 17.5 centimeters high, 25 centimeters deep, and 50 centimeters long. It's made from hollow concrete, which keeps it strong but easier to handle. The blocks fit together using a simple vertical plug-in system. No mortar, no plaster, just clean solid walls that go up fast. Around 12 blocks cover a square meter. They're shaped using PERI molds made from recycled plastic and plywood, designed to work well even in low-tech environments. Some blocks are also being tested with hempcrete, which could even lower their carbon footprint. The hollow design not only cuts down on concrete use, but also helps with heat insulation and fire resistance. Construction using these blocks is quick. In Kibera, one of Nairobi's largest informal settlements, a 3-story school was built in under a year using about 7,000 blocks. That school now holds 225 students and includes classrooms, bathrooms, and rooftop water tanks. The blocks have also been used to build homes, public toilets, boundary walls, small shops, and water enclosures. Because the blocks can be taken apart and reused, up to 80% of them, it's easier to adapt buildings as needs change. These blocks were first used in Kibera, and production happens right there in the community. Small local factories, often run by women and young people, make them using simple, reusable molds. Each person can produce about 75 blocks a day. By the end of 2022, there were 4 such sites in Kenya, and plans are in motion for mobile factories in South Africa. The blocks are also flexible, literally. Builders can create curved or irregular walls, which is helpful in crowded or uneven areas. Since no plastering is needed, projects finish faster and cost less. This 3-part polymer aggregate system is designed for serious infrastructure repairs, bridge decks, highways, elevated parking areas, and more. It combines high-performance resins with specially chosen aggregates to create a dense, impermeable surface that holds up under heavy use. It can be applied in a single lift from 1/2 inch to 12 inches thick, and roads can typically reopen just 2 to 3 hours after it's put down. The formula contains no VOCs or strong odors, which means it's safe to use even in enclosed or sensitive locations. It bonds directly to properly prepared concrete, no primer needed, and the surface can be textured or treated with a friction aggregate to meet safety standards. The resins are engineered to meet strict environmental requirements, and the aggregates are selected for strength, traction, and resistance to wear. Before installation, the concrete surface must be thoroughly cleaned and prepped, usually through shot blasting, to make sure the material adheres properly. While the system supports lifts up to 12-inch thick, local regulations may place limits. For example, Mississippi dot caps overlays at 3 inches per lift. Exact mixing ratios are proprietary, but available in technical sheets. The material is flexible enough to handle the natural movement of concrete as temperatures change, which helps prevent cracking over time. A representative from the manufacturer is usually on-site during installs to make sure everything goes according to plan. It's been put to the test in the real world. In Missouri, it helped extend the life of Route Y's bridge deck by decades. In Los Angeles, Caltrans used it on the I-405 Van Nuys Bridge. And on Highway 65 in Missouri, it was used to correct the deck level and get traffic flowing again just hours after placement. When it comes to 3D concrete printing, precision and reliability aren't optional, they're essential. Sikacrete 3D materials are made to meet the demands of robotic and gantry printing systems, where clean lines, consistent layering, and dependable performance matter from start to finish. Whether it's an architectural feature, a sculptural element, or a full-scale structure, this mix is ready for the job. The formulas use fine aggregates, mostly under 1 mm, to keep finishes smooth and equipment wear to a minimum. In slower or larger projects, like house-sized prints, Sikacrete 3D allows for grain sizes up to 3 mm, giving operators more time between layers. Color options include light gray, white, and standard concrete tones, chosen for easy pigmentation and aesthetic control. With a dry bulk density of about 2.14 kilograms per liter, the material balances flow and strength. It performs fast, hitting around 30 megapascal of compressive strength in just 24 hours, and reaching 50 megapascal by day, 28 at 20 degrees Celsius. Flexural strength grows from 3.5 megapascal on day 1 to 10 megapascal after 4 weeks, and the elastic modulus lands near 31 gigapascal. Water needs fall between 14 to 15% by powder weight, and pot life ranges from 10 to 20 minutes depending on temperature. Set times adjust to conditions. Initial set can take 35 to 80 minutes, and final set finishes between 45 and 90 minutes. Silka Tempo is a large format lime sand block designed for fast, efficient wall construction. Each block measures about 49.8 by 60 centimeters, with standard thicknesses of 18 or 24 centimeters. 24 centimeters block weighs roughly 140 kilograms and has a dense structure, around 2,000 kilograms per square meters, which gives it strong load-bearing and acoustic properties. It reaches a compressive strength of 20 Newton per square millimeter, handles freezing conditions well, and is fully non-combustible, Class A1, with fire resistance lasting up to 240 minutes depending on the wall setup. Acoustic insulation hits up to 59 decibels, suitable for residential or hotel use. A newer option, Silka Tempo Lite, was launched in 2024. It has the same dimensions, but a hollowed core, cutting weight by about 22% and reducing density to 1,600 kilograms per square meters. While slightly lower in strength, it still delivers solid performance, with acoustic insulation around 57 decibels. Because it uses fewer raw materials, it also trims the carbon footprint by around 20%. Transport becomes more efficient too, since more blocks can fit in a single truckload. The blocks are lifted and placed using a mini crane, allowing a two-person crew to put up around 50 to 55 square meters of wall per day, over 50% faster than traditional masonry. Zella supports the system with digital planning through BIM, providing detailed structural layouts and cutting prep time by up to 70%. Material use also drops slightly, saving about 5%. Projects in Slovakia and the Czech Republic have already used the system to speed up builds, lower costs, and meet strict fire and sound standards. It lays a tile every 40 seconds, handles everything from glue application to leveling, and never needs a break. Designed for 80 by 80 centimeters tiles, common in modern construction, this robot moves through floor plans using SLAM navigation and visual positioning to stay on track. It places each tile with less than 0.5 millimeters of variation and uses a vibration mechanism to press them down firmly, avoiding air pockets or uneven surfaces. Glue is applied with an onboard dispenser that keeps the layer consistent, and leveling sensors make sure the result is flat and flush. It works best on flat indoor surfaces, whether in open areas or right up against walls. Once set up with layout parameters, it runs on its own, picking up tiles, applying adhesive, and setting them in place. A single person can monitor its progress, top up the adhesive, and reload tiles. While the power source hasn't been officially confirmed, it's likely either battery or tethered. Made in a high-tech facility in Guangdong, this robot has already proven itself on big jobs, like tiling sections of Guangzhou Baiyun Airport Terminal 3. It ran for long hours without missing a beat. No misalignment, no interruptions. At BOMA 2025 in Munich, it handled complex layouts with ease, moving along walls and around obstacles without sacrificing precision. Its performance stayed consistent, tile after tile, hour after hour. What used to take a team of workers can now be done by one person supervising the robot. No more kneeling for hours, manually spreading glue, or checking if every tile is level. It strips out the repetitive, error-prone parts of the job and replaces them with speed, accuracy, and reliability. For large flooring projects, it changes the game completely. When tough jobs need doing, like clearing track ballast, drilling into hard ground, or trimming back overgrowth, RF System delivers tools that hold up under pressure. Take their ballast sweeper roller. It runs on a single hydraulic circuit, handles up to 140 bar of pressure. It clears ballast fast, no shovels needed. Their clamshell bucket grabs and moves debris, whether the task is vertical or horizontal. The BOR auger drills into solid terrain for core samples or hole making, while the hydraulic branch cutter bar slices through branches up to 10 centimeters thick, ideal for clearing railway embankments or roadside brush. Their bolted teeth stand up to brutal digging conditions and can be replaced easily when worn down. Every tool comes out of Sweden, where the company has been building attachments since 1978. Now part of the global Kinshofer Group, they still keep everything from design to final assembly in-house. That means tighter control, faster adjustments, and products that match real job site needs, not just design specs. These tools aren't dreamed up in boardrooms. They're shaped by conversations with operators, tested on actual machines, and refined until they work the way they should. And they last. RF System keeps parts on hand even for older models, so downtime stays short and machines stay working. While the company now reaches customers around the world, its mindset stays practical and grounded. They're not chasing trends. They're building tools for crews who rely on their equipment to work every day. Moving heavy material doesn't have to be slow, messy, or labor-intensive, and this machine proves it. At 21,000 pounds and just over 22 feet long, it's designed to handle the kind of jobs that usually eat up time and manpower. It loads up to 7 cubic yards at once and uses a 14-foot hydraulic belt to launch material as far as 150 feet. With all-wheel drive and 3 steering modes, crab, pivot, and differential, it handles tight spots, rough ground, and slopes without getting stuck or off balance. A 6-foot loading height makes it easy to fill from the back or side using standard loaders, and the auto leveling system keeps it steady even on uneven terrain. Instead of climbing into the cab, the operator runs everything with a radio remote. That means better visibility, more control, and less exposure to flying debris or equipment hazards. The tires are designed for loose surfaces and job site movement, so it stays mobile without tearing up the ground. Where shoveling 20 cubic yards might take a team 20 hours, and a skid steer might do it in 2, this Slinger can get it done in just 8 minutes. It cuts down on labor, reduces equipment shifts, and helps projects wrap up faster. It's used for all kinds of jobs: trench backfill, soil and mulch placement, erosion control, pipeline work, even road shoulders and mining sites. Because it can hit exact drop zones from a distance, it saves cleanup time and avoids damage to the surrounding area. Setup is quick. Position the unit, load it with a skid steer or side loader, and run the whole operation remotely. As long as the hopper stays filled, material keeps flowing. This fiberglass insulation is designed to make construction faster, cleaner, and more efficient, whether for homes or commercial spaces. It's made from glass fibers held together with a special binder that contains no added formaldehyde, and it's available in unfaced, craft-faced, and foil-faced options depending on the market. The insulation comes in R values from R13 to R49, with thicknesses ranging from 3.5 inches up to 14 inches. It's sized to fit standard framing, 15 inches wide for 16-inch spacing, and 23 inches for 24-inch spacing, with bats and rolls in various lengths. Density varies by type, but generally falls between 0.5 and 2.0 pounds per cubic foot. The fiberglass won't burn and won't soak up water or allow mold to grow. It also reduces sound, helping walls reach sound ratings of 35 to over 50, depending on how it's installed. One of the first things installers notice is how much cleaner and softer it feels compared to older fiberglass. It produces far less dust, doesn't irritate the skin the same way, and holds its shape when placed into wall cavities. That means fewer cuts, no slumping, and quicker installs, up to 23% faster, according to field reports. It performs well when it comes to keeping heat in or out, helping buildings meet today's strict energy codes. Made with over 50% recycled glass and certified for low chemical emissions, this insulation supports sustainable building goals. It can lay brick roads between 4 and 6 meters wide in a single, smooth pass. Powered by either a diesel engine or a fully electric system, it's designed to handle large surfaces with minimal fuss. The electric version, called the RoadPrinter Eco, runs on a Mastervolt lithium-ion battery pack and can go for an entire week on one full charge. It plugs into standard power sources and charges quickly thanks to a multi-stage system. The machine moves on 2 wide rubber tracks, each guided by 8 rollers, distributing weight evenly and gripping the ground firmly without damaging it. Sensors along the front of the machine help it follow curbs or brick lines automatically, keeping each row straight. A fast-moving conveyor belt feeds bricks into place up to 3 times quicker than older systems. And because it doesn't rely on generators, external cables, or too many moving parts, it's easier to run and requires less upkeep. It can handle a wide range of patterns, including herringbone at 90 or 45 degrees, block bond, vertical herringbone, and others, complete with edge bricks set during the same run. Here's how it works. Workers load stacks of bricks into the machine, already arranged in the right pattern. Gravity pulls the bricks down a chute where they settle naturally into place. There are no robotic arms or motors forcing them into position. It's all handled by the machine's angle, design, and steady motion. By turning a slow, back-breaking job into a clean, efficient system, this machine lets paving crews focus on setup and quality control rather than placing each individual brick. It climbs without a crane. That's what sets the SCF60 apart. This self-climbing formwork system is designed for vertical concrete construction, moving upward with each pour using hydraulic brackets that grip and push along the building. Each bracket handles up to 150 kN of vertical load and supports formwork panels as high as 5.5 meters or as wide as 17 meters. In some setups, that width extends to 8.5 meters. A single pump controls up to 8 brackets at once, allowing the entire system to move in sync, forward, backward, sideways, even around curves. The SCF60 creates fully connected workspaces at every level. The main working platform is about 3.20 meters wide, with additional trailing and pouring decks measuring 2.30 meters and 1.5 meters. Its side railings stand 2.5 meters high, while the formwork modules themselves reach up to 6 meters. It adapts easily to wall offsets, up to 50 millimeters with no changes, and up to 150 millimeters with slight adjustments. It's also been tested to hold steady in wind speeds, reaching 208 kilometers per hour. Safety is built into every part of the design. The system includes back rails, guardrail posts, self-closing gates, and enclosed decks, giving crews protection on all sides. The hydraulic system has built-in backup, and the entire setup is managed by a mobile pump to keep operations moving. There's even an extra deck above the main platform for rebar work and material handling. The SCF60 meets major international safety standards across Europe, the UK, and the US. It's designed to move with the structure, cutting out crane delays and keeping work flowing smoothly between pours. In large spaces where sound bounces and air can feel stale, this sealing system works quietly in the background to improve both. At its core is a gypsum board mixed with natural zeolite, an ingredient that continuously breaks down airborne pollutants, odors, and volatile organic compounds into harmless elements. No filters, no refills, just steady performance that lasts for the life of the panel, even after painting. The system meets acoustic standards and can achieve sound absorption ratings from Class D up to Class B, depending on how it's installed. Add mineral wool insulation, at least 40 kilograms per cubic meter, and increase the cavity depth, and it reaches Class B. Good enough for classrooms and hospitals where sound control matters most. Installation is simple. The panels fit into a suspended metal grid using CD 60 by 27 channels. Typical setups drop about 196 millimeters from the ceiling and stay under 0.15 kilonewtons per square meter in weight, though that can increase with extra layers. There are 3 edge styles to choose from: square cut, pre-beveled, or linear rebated joints. The linear option is the quickest to fit and doesn't need joint filling, saving time on site. Design-wise, there's a lot to work with. Choose from 16 standard perforation patterns, round, square, or rectangular, with either black or white backing fleece. Patterns are made to align across panels, keeping the ceiling clean and cohesive. Non-perforated edges are also an option for finishing touches. Once primed, panels are ready for painting without losing their air cleaning function. This system fits well in places like offices, schools, hospitals, and transit hubs. Anywhere clear speech and cleaner air make a difference. It also meets fire safety standards when combined with Knauf-rated ceiling systems. This system uses aluminum panels that reach up to 160 by 160 centimeters, weighing just 16 kilograms per square meter. They're easy to handle, thanks to closed profiles and powder-coated surfaces that clean up quickly. Panel widths come in 40, 60, 80, and 160 centimeters. Beam lengths vary, from 270 down to 40 centimeters, across primary, secondary, and compensation types. The facing is a solid plastic sheet, giving a consistent concrete surface and standing up well to water exposure. For HN setups, 3S shuttering panels or similar options can be used. Drop heads allow props and panels to be lowered by around 19 centimeters, which speeds up removal. Support comes from UMAX props and MT60 towers, covering heights up to 21 meters. It works in 3 slab forming methods using just 1 set of parts. The FTE method uses panels, primary beams, and drop head props to handle slabs over 30 centimeters thick. It's designed for quick reuse once the concrete has set. The HN method adds secondary beams and gives flexibility with the choice of facing sheets. The E method is the simplest, just panels and props, and it's good for tight or uneven areas. Prop heads hold the panels firmly without extra tools. Since it's grid-free in one direction, primary beams can be laid out to avoid unnecessary filler panels. In the E method especially, fewer props are needed, which can reduce material use by up to 40%. According to tests from the IZB Institute, it's about 10% faster than similar systems, putting down a square meter in 13 minutes instead of the typical 16. Over 1,000 square meters, that can save around 50 hours of work. BIMPrinter is a mobile robot that takes digital floor plans and prints them directly onto construction surfaces, concrete, wood, asphalt, even roofing, with pinpoint accuracy down to 2 millimeters. It can trace everything from lines and curves to framing, text, and quotes, and it works on slopes up to a 15% grade. It reads DWG, or DXF files straight from design software and connects easily with total stations from Leica, Trimble, Topcon, and Sokia. The system fits into modern construction workflows, combining data from drones, laser scanners, GNSS, and XR projection tools, with software support and manufacturing handled by Decimone SA and Plasturgi Lazzarini. Instead of measuring by hand or guessing from blueprints, crews can now print their layout directly on-site with digital precision. In Geneva, the firm Hallerwasser plus Partner SA uses BIMPrinter to manage complex layouts for residential and industrial projects. Curved designs, which usually take time and skill to mark manually, are now handled cleanly and quickly by the robot. The tech has been field tested across Europe and the US and Belgium. Eurocontrol used it to lay out safety infrastructure down to the millimeter. In Paris, teams printed key construction notes directly onto concrete slabs. In Dallas-Fort Worth, a single operator ran several units at once to mark hundreds of thousands of points, something that would have taken days by hand. Even specialty use cases like sports fields have benefited. Proludic used BIM printers to map out detailed lines and patterns for recreation spaces. Just one person can lift and set a 6 by 3 feet panel, because it weighs just 86 pounds. That kind of usability is at the core of the MevaLite vertical wall formwork system, which is tailored for US construction standards in feet and inches. Panel heights range from 3 by 9 feet and widths go from 6 inches up to 3 feet. Despite being lightweight, the system handles concrete pressure up to 1,350 per square foot. It's built with powder-coated, closed-profile aluminum frames and Alcus composite facings that leave a clean finish and can be repaired directly on site. The clamp system is quick and simple. It's a single piece that locks into place with just a few hits from a hammer. No bolts or nuts to deal with. The frame has built-in threaded sleeves, so workers can pre-attach accessories and tie systems before lifting panels in gangs. These gangs can be lifted by crane up to 18 feet high. Anything taller just needs multi-lift planning or engineering input. MevaLite also includes multi-purpose panels that handle corners, columns, pilasters, and wall transitions. They're designed with tie holes spaced for inch-by-inch adjustment, so builders can shape pilasters up to 24-inch wide. Fillers come in aluminum or job-built lumber, with widths ranging from 1 to over 6.5 inch, depending on support needs. At full pressure capacity, the system can handle fillers up to 40-inch wide when used with steel rails. Corner units include both fixed and articulated panels with levers that make stripping and resetting fast. The tie system uses 5/8-inch thread bar taper ties, rated at 18.75 kip safe working load, and flange nuts provide secure fastening. To keep everything aligned and safe, there are bracing props, guardrails, walkway brackets, and shoe plates, rated for up to 2,000 pounds of uplift when anchored right. Heap is no ordinary excavator. Originally a 12-ton Menzi muck with a spider-like chassis and adjustable legs, it's been re-engineered by researchers at ETH Zurich into an autonomous machine that handles heavy lifting and complex terrain on its own. It uses hydraulic cylinders to adjust its stance on the fly, and encoders to track every movement of its boom and arm with precision. To understand its surroundings, it relies on 2 LiDAR sensors, one on the cabin, one on the boom, that create detailed 3D maps of the work area, even in dusty conditions. It also uses centimeter-accurate RTK antennas, an IMU for orientation, and sensors in each joint for constant feedback. Cameras can be added, but LiDAR does most of the work. Heap doesn't just move, it thinks. It scans stones on site, figures out their shape, weight, and balance point, and decides how each one fits into a digital wall design. It works in batches, picking 20 to 30 stones at a time, and calculating how to place them safely and efficiently. Then, using a rototilt gripper, it picks up each stone and puts it exactly where it should go, No manual control needed. The team tested HEAP by tasking it with building a 6-meter-high, 65-meter-long dry stone wall at Circularity Park near Zurich. It used only found material from the site, mostly debris and leftover stone. It sits on a pallet, lifted easily by a forklift or crane, and takes on serious loads without fuss. This kind of bulk bag, made from tough woven polypropylene, is designed to carry everything from grain and fertilizer to construction debris or mining material. The fabric weight varies between 140 and 240 grams per square meter, depending on how strong the bag needs to be. Seams are stitched, sealed, or made dust-tight to keep fine materials from spilling out. It usually has 1 to 4 lifting loops stitched at the corners or seams, depending on how it's meant to be moved. The top can be fully open or designed with a flap, skirt, or spout to control how material gets loaded. The bottom might be flat or have a spout, or quick release setup for easier emptying. Some models include internal panels, called baffles, that help the bag keep its shape when full, especially useful when stacking or storing. Sizes vary, but a common example is 90 by 90 by 100 centimeters, holding around 810 liters, and safely carrying up to 1,000 kilograms. These bags are usually rated with a 5 by 1 safety factor, tested to hold 5 times their intended weight. Larger versions can handle even more, up to 3,000 kilograms in some cases. Most bags include printed labels with their weight rating, safety specs, and tracking info. They come in different panel styles: U-panel, 4-panel, tubular, vented, or baffle, to suit how they're used and stacked. Some have mesh sides for things like onions or potatoes. Others are certified for transporting food or hazardous goods. This pipe system, made from polyethylene, is designed with a layered wall structure that balances strength and efficiency. It meets key international standards and is produced under strict ISO controls. The SN4 rated version has a density of about 940 kilograms per square meter, tensile strength over 15 megapascals, and can stretch more than 350% before breaking. It's also stable under pressure, with a short-term stiffness of at least 800 megapascals. Pipe diameters range from 0.3 to 3.5 meters, and lengths are usually 12.5 meters, but can be adjusted. First developed in Finland in 1983, this system has since been used worldwide through Uponor Infra and its partners. It's designed to last for decades, even under heavy use, and stands up well to physical stress and wear. There are several connection methods available: welded joints for a seamless fit, automated options for larger pipes, and mechanical joints suited for various site conditions. The system includes all the needed fittings, bends, tees, reducers, and can be customized to match specific project needs. Larger items like storage tanks, access shafts, and manholes are built to order. Long pipe runs cut down on jointing time, and mobile plants can produce pipe sections right at the job site. The extended size range, known as Weholite Plus, also supports European environmental goals. Made from a mix of glass or carbon fibers set in tough resins like polyester or epoxy, OptemFRP pedestrian bridges meet demanding industry standards for strength and stability. These structures handle tension and compression around 207 megapascal, resist shearing forces up to 4 ksi, and maintain stiffness near 19,300 megapascal. Their decks are made from hollow box-shaped profiles, joined with adhesives or mechanical connectors, and finished in the factory with slip-resistant surfaces. Each bridge is designed to limit bending under foot traffic and to avoid noticeable vibrations, keeping movement smooth and comfortable. One real-world example, the bird-ridding footbridge, spans almost 15 meters, carries up to 5 kN per square meters and flexes only 34 mm under load while maintaining steady performance. Installation is fast and manageable. Since the bridge modules arrive ready to assemble, crews don't need much more than a crane or excavator. In Kremsko village, Poland, workers installed an OptemFRP bridge quickly using basic equipment, saving time and avoiding major disruption. That kind of setup works well in remote places or where construction access is limited. The materials hold up against sunlight, chemicals, and shifting temperatures. And while these bridges weigh much less than traditional ones, they're carefully designed to handle foot traffic without swaying or bouncing too much. Engineers use advanced modeling and real-world testing to make sure the structure moves naturally without becoming uncomfortable. Compared to steel or concrete bridges, which often need frequent maintenance, OptemFRP bridges offer a longer working life with fewer repairs. Steel can rust and concrete wears down. The composite structure holds up better over time. Though the upfront cost is higher, the savings over the years make up for it. These bridges are already in use across Europe and North America, especially in areas that need quick installs, fewer disruptions, and solid long-term performance. FIRECOAT exterior and interior paints deliver strong fire protection through a formula backed by clear technical performance. Each coat goes on thick, micrometers wet, with a single liter covering around 1.43 square meters. For the exterior version, one coat gives enough protection for BAL29, while 3 coats, reaching 1 mm dry, meet the higher BAL40 rating. The interior version follows the same approach. About 340 micrometers wet dry on wood and up to 1 mm for plasterboard surfaces. It's certified under European and Australian fire standards. Both paints dry to the touch in a few hours, depending on temperature and humidity, and reach full strength in about a week. Stored properly, unopened containers remain usable for up to 2 years. Developed in Australia by Flame Security International with researchers at UNSW, these water-based undercoats are designed to slow fire down in critical moments. FIRECOAT exterior, a light grey formula, is made for outside surfaces in high-risk bushfire zones. FIRECOAT interior, in white, is made for walls, ceilings, and timber finishes inside. When exposed to high heat or direct flame, both coatings react by forming a thick protective layer that helps keep fire from penetrating further. Testing shows they can hold off flame for over 30 minutes, even under direct ember attack, without the structure giving way. To apply, the surface should be clean, dry, and free of loose material. The paint should be mixed thoroughly from the bottom up. It can be brushed, rolled, minimum 20 mm nap, or sprayed using a high-pressure airless system. No thinning is needed. Once fully dry, you can paint over it with a compatible water-based acrylic. Just test a small area first. Cleanup is easy with cold water. Proper gear and ventilation are recommended during use. This connection system is designed to create solid, reliable joints between precast concrete elements like walls and columns. At its core are galvanized steel rails, each 1.25 meters long, with 5 steel wire loops spaced at fixed positions. These loops, made from high-strength alloyed steel, are what allow vertical rebars to be inserted later on, locking everything together once the joint is filled with structural grout. 2 rail heights are available: WILORA 50, 50 mm, and WILORA 20, 20 mm. Often used together depending on the type of joint being built. Each rail section has a base width of about 70 mm, rail width of 50 mm, and a loop diameter around 6 mm. The loops remain sealed during casting thanks to protective tape or plastic film. On site, the loops are bent open and rebars are threaded through them. After the precast panels are positioned and braced, grout is pumped into the joint to finish the connection. The system is made to handle tensile forces, vertical shear, and transverse shear loads, all without transferring bending moments, meaning the joints work like hinges when needed. A single loop pair in standard C25/30 grout can carry about 7 kilonewtons in tension, adding up to around 28 kilonewtons per meter, depending on spacing. Transverse shear strength can range from 16 kilonewtons per meter to 23 kilonewtons per meter. Installation starts at the factory and finishes on site with basic steps and clear tolerances. Supported by digital design tools and approved in multiple countries, the system is used in everything from housing to industrial buildings. Airium comes in a range of densities, from 50 to 1,000 kilograms per square meters, each offering different levels of insulation and strength. At the low end, it delivers excellent thermal performance. Higher density versions reach up to 5,000 kilopascal in compressive strength. Vapor resistance varies between 3 and 40, depending on the grade. All types require at least 4 centimeters of thickness and meet top fire safety standards. A1 with 0 VOC emissions. A 10 centimeters layer typically achieves an R value between R10 and R16. When applied around 20 centimeters thick, it also helps reduce noise, with a sound absorption rating near 0.06. The material allows vapor to pass through, helping to avoid trapped humidity and related air quality problems. Instead of being manufactured in a factory, Airium is mixed and poured on site. It's made from a simple blend of cement, slurry, and foam, which creates a matrix full of sealed air pockets. Once it sets, the result is a solid insulating layer that doesn't rely on chemical additives. It doesn't attract pests or support mold, and when it's no longer needed, it can be broken down and reused in cement or concrete mixes. Because it's made and applied where it's needed, it cuts down on transportation and packaging. And thanks to its mineral content, it even has the potential to absorb CO2 from the air over time. Airium is used in a wide range of building applications. It works under floors and slabs, replacing both insulation and filler layers. It can support foot traffic when applied in thicker, denser grades. It's used in attics, either for loose fill insulation or structural base layers. On flat roofs, it creates both slope and insulation in a single step. It also fills wall cavities, improving insulation performance, and serves as a stable fill for tunnels, voids, or backfill in civil engineering projects.